So this video is a continuation of the last video where we seen taxonomy diagram and its sub-technologies come under it. Now we will move further and see remaining technologies. So now we going to see techniques used in the virtualization. Here we see process level virtualization techniques, in which we will see emulation. So let's understand emulation. First, understand what is emulation means. Emulation is termed as the ability of a computer program to replicate, or imitate, another programmed or system within an electronic device. Generic simple example: several printers are designed to imitate HP laserjet printers, since so much software for a HP printers is written. If a non-branded printer emulates with a branded printer, the non-branded printer. Emulation can also run any program written for a real branded printer, and it can even generate the equivalent printing. Now let's go forward and see how actually emulation works. Emulation is a technique used to simulate the behavior of one system on another system. It involves creating a software environment that mimics the hardware and software of a different system, allowing software designed for that system to run on the emulated system. In other words, emulation enables a computer or device to imitate the functionality of a different computer or device. First, for example, you might use an emulator to run old video games or software designed for an older operating system on a newer computer. Second, emulation can be especially useful when trying to preserve old software or hardware that is no longer in use, but still important for historical or research purposes. It allows you to run these programs on modern hardware, even if they were originally designed for outdated systems. Third, however, emulation can be slower than running software natively, as the emulated system has to translate its instructions to the host system's architecture. It can also be more resource-intensive, as the emulated system requires its own resources to run. Explanation of paragraph. Emulation is like pretending to be something you're not. In the computer world, it means making one computer act like another computer. This can be useful when you want to run old software on a new computer, or if you want to use a computer program that was designed for a different type of computer. Emulation is like speaking a different language. You have to translate what you want to say into the other language, and the person you're talking to has to translate what they say back to you. This can make things slower and more complicated. However, emulation can be helpful when you want to use something old or outdated, but still important. It lets you run the old thing on a new computer, so you can keep using it even if it's not made anymore. Now, let's understand high-level VM. So what is high-level virtual machine? A high-level virtual machine is a software emulation of a computer system that abstracts the underlying hardware and provides a platform for running software applications. It operates at a high level of abstraction, meaning that it provides a software environment that is as close as possible to the application programming interface, API, of the underlying hardware platform. In a high-level virtual machine, the guest operating system is not aware that it is running in a virtualized environment, as it is provided with a complete set of virtualized hardware resources, including CPU, memory, storage, and network interfaces. The high-level virtual machine software handles the mapping of these virtualized resources to the physical hardware, providing a layer of isolation and security for the guest operating system and applications. High-level virtual machines are widely used for software development, testing, and deployment, as they provide a consistent and reliable software environment that can be easily replicated across different hardware platforms. They are also used for server consolidation, where multiple virtual machines can be run on a single physical server, maximizing hardware utilization and reducing costs. Explanation of paragraph. A high-level virtual machine is like a computer program that pretends to be a real computer. It gives software programs a virtual environment to run on, without them knowing they're not running on a physical computer. The virtual machine software provides the virtualized hardware resources like the CPU, memory, storage, and network interfaces, which are mapped to the physical hardware by the software. These virtual machines are helpful in software development, testing, and deployment, as they provide a consistent and reliable software environment that can be easily used on different hardware platforms. They're also used for server consolidation, where multiple virtual machines can run on one physical server, saving costs and maximizing hardware usage. Now we should look up to multiprogramming. Multiprogramming in virtualization refers to the ability of a virtualization platform to run multiple virtual machines, VMs, simultaneously on a single physical machine. This is achieved by sharing the physical resources of the host machine, such as CPU, memory, storage, and network interfaces, among multiple VMs. In a multiprogramming environment, each VM operates independently of the others and has its own operating system and resources. The virtualization platform manages the allocation of resources to each VM, dynamically adjusting resource usage based on the demands of each VM. Multiprogramming in virtualization allows for efficient utilization of hardware resources, as multiple VMs can share a single physical machine, reducing the need for multiple physical servers. It also provides a high level of flexibility, as VMs can be easily created, deleted, and migrated between physical machines, allowing for easy scalability and resource management. Multiprogramming is a key feature of virtualization and is widely used in various industries, including cloud computing, data centers, and software development and testing. Explanation of paragraph. Multiprogramming in virtualization refers to the technique of running multiple programs or applications simultaneously on a virtual machine, without interference between them. This approach makes efficient use of the available resources, allowing the virtual machine to execute multiple tasks at the same time. The virtual machine manager ensures that each program or application running on the virtual machine has access to the required resources, such as memory and CPU time, without affecting the performance of other programs running on the same virtual machine. This technique is commonly used in cloud computing environments to improve the utilization of computing resources and enhance the overall efficiency of the system. Now we reached the end of multiprogramming and covered all topics of cloud computing taxonomy, process-level techniques, such as emulation, high-level VM, multiprogramming, and this is the end of the process-level cloud computing taxonomy, virtualization technique.